Hey everybody, thanks for dropping by. So today we're doing a cold startup of the Citroen GS. After improving the ignition coil and fixing the broken wire of the idle solenoid, we'll be attempting to start her up after just 48 hours inoperable, during which, however, the temperature was hovering around the 0-degree mark, and as you can clearly see, there is a bit of snow as we speak. So let's see how fast it'll start, if it will start at all, how fast it will lift up, and generally if this old-timer still has a spark left in him. This is also a great chance to check out the other improvement I've done on the fuel line, where I've installed a PTFE tube in place of the traditional rubber fuel hose. Well, it sure took its time, but hey, 4 seconds is not all that bad for such an old engine. Looks like this old dog is not about to kick the bucket anytime soon. Now, it's worth noting that when turning on the switch, the hydraulic pressure light on the dash was not on. And this is important because it shows that the hydraulic system in this car is in pristine condition. That's how it's supposed to be. That's how it should work. There has been quite an extensive work done on the hydraulics on this car, and any leaks or faults have been fixed. That's why the system is totally sealed, and that's why the pressure doesn't drop even after 48 hours of inoperability. And as we can see, after just 30 to 40 seconds after startup, the car lifts up. Yes, that's how it's supposed to be. Okay, now let's have a look around and check out this new PTFE Teflon tube I've installed in the fuel line. I only changed the part from the pump to the carburetor, which, as you can see, includes a small filter. And actually, the part before the filter is an 8mm copper pipe. You can barely make out the pump down there, right there, while the rest of the line, from the filter to the carburetor, is all Teflon tube. And while we're here, let me introduce you to the new accumulator return line, which is also a Teflon tube, 12mm outer diameter and 15mm outer diameter copper pipe, ending up in this small collector and with a small piece of rubber hose ending up on the hydraulic fluid reservoir. Okay, the reason why I chose to install that Teflon tube. First of all, out of curiosity. See, this engine is quite unreliable and it can lend itself as a test bed for new materials. Now, rubber fuel hoses generally tend to deteriorate after some time. Cheap ones will deteriorate faster, more expensive ones will last longer. So I thought, what if we could install a tube that is more reliable and more durable than a traditional rubber hose? That's why I came up with the idea of the Teflon tube. Now, Teflon tube doesn't take bends that nicely. That's why I decided to add the copper pipe in the first part, before the filter, to make a more tight and neat bend around the air filter box and leave the part after the fuel filter as is, pure Teflon. There's also another reason. Now, this one I found on the internet, so take it with a grain of salt. So the internet mentions that traditional rubber fuel hose is permeable. This means that any gas inside the hose can migrate from inside the hose to the outside environment. And since petrol is volatile and has fumes, these fumes, being a gas, can slowly migrate through the rubber hose to the outside environment. And slowly the hose will become empty of fuel. Now, this doesn't happen immediately, within a couple of days. No, we're talking about a couple of weeks, maybe a month. But regardless if the information is correct or not, wouldn't it be nice if the tubes we've used were not permeable? I mean, it will eliminate even the remote possibility of the fuel actually permeating through the rubber, as the internet suggests. That's why I've used the top of the line material, Teflon tube, and maybe that's why modern cars don't usually have rubber hoses in their fuel lines. Now, my only worry is that the Teflon tube might react with petrol, or petrol corroding the copper pipe. See, petrol is known to be a solvent, and I've read in the past that it reacts with Teflon. It's been now a couple of weeks since I've installed that tube, and I haven't really noticed any problems with it. So if anyone has any information regarding the interaction between petrol and Teflon or copper pipe, feel free to share. Now, for the record, there is another alternative to the copper pipe, and that's the so-called conifer pipe or Cu-Pro pipe. That is a copper alloy containing nickel and iron, if my research is correct. It is generally used in brake circuit plumbing in 3/16 inch diameter, but it's also suitable for fuel lines, and there are other dimensions available. In our case here, we needed the 8mm or 5/16 inch diameter. This dimension, although it is available in Cu-Pro pipe, apart from pure copper, now we didn't have it. I just had pure copper available, so that's what I've used. I'm gonna monitor the whole part and see if it develops any faults or if it causes any other symptoms, and I'll move accordingly. So anyway, that's it for this video. Just a small presentation of a new generation part to be tested in a 40-year-old test bed. If it works, it's going to be a great demonstration of how modern day materials can improve reliability in older cars. If it doesn't, well, I do carry a piece of traditional fuel hose in the trunk for just in case. Next video is probably going to be a fix of another gear stick knob, this time on a Peugeot 307, so stay tuned for that. Any questions or comments, don't hesitate to leave them below, and thank you very much for watching. You are the best!